Inequalities are fun. We know 3 is less than 5, and it makes sense. We can all agree on it. Does it also work with complex numbers? Is 3i plus 3 less than 5i plus 5? Sadly, the answer is no. So let's talk about it. If we have a number line, we can put all the real numbers on this number line. Here's 0, and 3, and 5. We can put them in an order. When comparing two numbers, the one further to the right is the larger number. And if two numbers are located at the same point on the line, they're equal to each other. We call this the real number line. Complex numbers like this are composed of real numbers and imaginary numbers. They can't be expressed on the real line. So we have to introduce another axis. We call this the imaginary axis. Now we can plot 3i plus 3 on this coordinate plane, and we can plot 5i plus 5. And we can imagine a line through 0, 0, and these two other points, and we could argue that 3i plus 3 is less than 5i plus 5. But not all complex numbers are on this line. They could be anywhere in the plane. For example, 6i plus 2. How would we order these 3 points? One logical approach is to look at the distance they are from 0. This is called the magnitude, and this is the notation for each of them. Using the distance formula or the Pythagorean theorem, we can find out how far they are from the origin, and here's the decimal approximations for each of them. It would be correct if we made this inequality statement about the magnitudes of them. The reason for this is because we can put these magnitudes in a linear order. We can plot them on the real number line. The magnitude of 3i plus 3 would be right here around 4.24. The magnitude of 6i plus 2 would be right here around 6.32, and this one would be right around 7.07. So magnitudes can be compared. It's clear which one's greater, which one's less, because they're put on a line. Can we say the same thing about the numbers themselves, not just their magnitudes? And the answer is no, because we can't put them into a logical order, fit them all into one line in a certain order because it's a two-dimensional plane. Here's another way we can think about this. Let's look at 6i minus 2, and let's find its magnitude. Using the same method as before, we get approximately 6.32. These 2 points are the same distance from 0. Their magnitude is the same, so this would be equal. If we use the same magnitude logic to order stuff, we would then have to say that 6i minus 2 is equal to 6i plus 2. But that is not true. They are different numbers. They're located at different points in the complex plane. They're not equal. And this is kind of the heart of how we can't really come up with an order for all these things, because which one would we put in first? And since we don't have any way of saying which of these is larger, ordering the complex plane on a line, so inequalities just will not work. They'll still work with the magnitudes, and that's a great way to measure them. There's a lot of math that uses that. Inequalities won't work with complex numbers. You guys are awesome. Comment on what you'd like me to talk about next. I'll talk to you soon.